is not perfect, right? It's going to be an approximate. And so any value we use with the equation, you use the equation to find a value, is not going to be exactly what the real value was. Hopefully it's going to be very close, right? That's the objective. All right, we're back to the baby problem. This was the data we put in. Do you still have that in your calculator? Go to stat and edit. Do you still have the baby weights in your calculator? You should, unless you've done something since then. Remember?
SAT yesterday.
You weren't doing stat listed
No.
SAT. Or if you were, I haven't helped you. All right, so we got that. This data is still in our calculator. All right, so using the model found in example 1, what is the residual of the baby that is 5 weeks old? All right, now here's what I want you to do. I want you to compute it by hand first, and then I'm going to show you how to do it on the calculator, okay? But we know that a residual is, as Fred said, actual minus predicted. So for a baby that is 5 weeks old, what is the actual value? This baby was weighed, it's in the table, 4.4. Now, how are we going to get the predicted value? Well, we're going to go back to the model that we wrote. And, oh, shooty tooty, I didn't write it down. So, I'm going to have to recalculate it. This might be, I know some of you did, thank you, Alex. I didn't, and this is good practice for the rest of us who may have forgotten. So I'm going to go back to stat, calc, and this is linear regression. We're going to talk a little bit today about other regressions, but they told me in the problem to use linear, so I'm going to use linear. And I'm going to come up with my equation, which Alex told me is the same thing I got last time, 0.185 x plus 3.545.
Yeah.
So this is our model. This is the equation that our calculator came up with to help us predict other weights of other babies. Okay? Now, there would be no need for me to predict a weight for a 5-week-old baby because it's in my table, but I'm going to go ahead and do it anyway. So I either do it by hand or let my calculator do it by doing y of 5. Either way, I'm going to come up with a 4.47. Do the math or let your calculator do it. I get 4.47. So that is what my model predicted. So what is the residual value for a baby 5 weeks old? Negative 0.07. Now, what does that mean? Well, is it better to have a residual of negative 0.07 than a residual of 7?
Yes.
Yeah, the smaller the residual, the better the model is, right? What does it mean that it's negative?
It just means that the predicted value is smaller than the actual value.
Is that what it means?
It's below the line.
The predicted value is
Or
higher
yeah.
than the actual value. So in other words, the model overestimated. The model thought the baby would be slightly heavier than he actually was. So interpret this number. You're going to have to be able to interpret your residuals. This, first of all, is a very small number, so that means our model is relatively accurate, at least at this point. And the fact that the residual is negative, remember how it's calculated. The residual is negative, so that means the model overestimated, predicted the baby would be heavy. Okay? What would it mean if it come out to be positive 0.07? The model underestimated, because the actual would be a little bit higher. And we talked last time that we want some of both, right? We want to have some overestimate, some underestimate, so that we kind of know we're in the middle there somewhere.
When we're calculating the, like,
I don't know what you're talking about. Say.
when we make that equation, it says like y equals 0.15 or 0.85x.
Yep.
How do we know if it's y equals ax plus b or y equals a plus bx?
It's whichever regression you chose. So if you chose option 4, it's this. If you chose option 8, it's the other way.
You can do
Either one.
I
It's
tried to listen and
If
then
you
it
got
doesn't
zero
work.
for the
It
residual,
just
you
tells
just
you
model
stupid
it
terms that
back
don't know what they mean.
If you got 0 for a residual, that would mean that your model actually contains that point.
Okay.
So it would be extremely accurate at that point, but that doesn't mean the whole thing is
Yeah.
completely accurate. But at that point, it would be, yeah. And that wouldn't be totally unheard of for that to happen, because you've got all these scattered data points and you want a line that kind of goes through the middle. It could hit one of them. Yep. Okay. So predicted value we got, residual we got, we interpreted it, perfect. All right. Example 3. Using the model found in example 1, a baby that was 7.5 weeks old had a residual of negative 0.7. What was the actual weight of the 7.5 week old baby? Now, remember, this is your, formula, for lack of a better word, right? What do I know in that formula? What do I know? I know the residual is negative 0.7. What else do I know? Do I know the actual? No, because 7.5 is not in my chart. The only actual values you know are the ones in your chart. Do I know a predicted value? I'll just say X. I don't know it, but I can find it, right? How would I find a predicted value? Plug in 7.5 for my X. Use my chart, in other words, or use my equation, in other words, to come up with a prediction. And my prediction is 4.9325. Was that yours? Did anyone else get that number?
Yes.
Okay, thank you. Now, look at that. That's like a second grade equation. We can solve that, right? We can solve that. So what is the actual weight of the baby? Oh, what'd you get? Oh, wait, I just messed up. 4.2325. Okay, everybody good? All right, so now I need your attention. I need you really to be paying attention now, because pressing buttons shouldn't be hard. We're not gonna make it hard by being off task. Where's your calculator, Enzo?
I gave it to someone and they haven't returned it yet.
Well, Enzo, that's gonna be an infraction today, because we can't do this without a calculator, okay?
Sorry.
I'm tired of loaning out my calculators to people that are irresponsible and don't bring them. Who has your calculator? Would you rather not say?
No,
It's okay
I
if you'd
kinda
rather not
would
say,
rather not.
but go after them,
Fair.
okay? Go after them, you need your calculator. Everybody else have yours? here we go. We're going to, what's my problem say to do? I'm supposed to sketch the residual plot. So in other words, like this was a residual right here, I'm gonna plot all of the residuals for the points in my table, okay? So first thing we're gonna do, everything's in our table just fine. We're gonna go to stat plot. Okay, so stat plot, very first button on the calculator. Let's pick plot 1. And I need you to turn it on. So highlight on, press enter. And then I need you to go down, you should see an X list and it says L1, right? And what was L1 again? L1 were the whats? The X's? The X's? And now where it says L, probably says L2 for the Y list, we need to have residuals in there. Because if we left it L1 and L2, it would graph a bunch of points, but those would be the actual ordered pairs in the data table, the X's and Y's, and that isn't what I want. I want to know for this X, what is the residual? So, are you highlighting there where it says Y list? You're highlighting there where it says L2? Okay, I need you to go to your list, where it says list. So second list. So list is right above stat actually. Find it and look down that list. What do you see down there as an option? Go down there, press enter, and now it should say X list is L1 and Y list is residual, right? And now we're going to hit graph. And if you don't see anything, try Zoom 9, that might help. Zoom stat. And do you see something that looks, you should see your horizontal line, got a couple dots down here, a couple dots up here, and one down here. Did you get something that looked like that? How come there are 5 dots? 5 data points that we entered, right? We had 5 data points in our chart. Okay, you good? All right, now, I want you to press trace.
Wait, this is for.
What?
All of my plots are on the line.
All right, I'll look at it in a minute.
Hit Zoom 9, that's what I did.
Zoom 9.
Zoom 9, that's your stat, Zoom stat.
Thank you.
Now, if, didn't I say that? I think I said that. If you press trace, now you can see that first point right there has what coordinates? What is this? This is where X is 4. This was your baby that was 4 weeks old. And then what's the residual for it? -0.085. And then if you just arrow over, it'll go to the next one. And that says when X is 5, the residual is -0.07. Oh, we figured that out. Isn't that what we got when we did it by hand? And then you can just keep going through and you'll get all of them.
When you do second trace, what button do you click?
You don't do second trace.
I don't.
You just hit trace. Just hit trace. And then you can just keep arrowing to get from point to point. So it said draw a residual plot. So you're going to take what's on the calculator and you're going to plot it on your grid. Obviously, every time you do a residual plot, the middle is going to be 0 because you want some of your residuals to be positive and some of them to be negative, right? It won't happen on purpose, but if you ever end up with a residual plot where all the points are up here, something's wrong with your model, so you need to go back and figure it out. Okay, we all right with that? right, let's go to example 5. Got new data now, so we're gonna put in some new data. And so you need to be watching him because you need to know what to do here. All right, example 5. Which function type best models the data in the table? Linear, quadratic, cubic, or rational? Explain your answer using characteristics from the data in the table. I tell you what, before we do that, I'm going to kind of do this backwards a little bit because then we'll talk about why it makes sense that this is a quadratic regression. Did anybody think that when you looked at it? Did anybody think quadratic? I hope nobody thought line. Why not? Why would line not be good? Alex?
Because it starts going up at decreasing rate, and then it starts going down.
Yeah. I mean, obviously, your X's are all getting bigger, right? What are your Y's doing? Well, they're getting bigger for a while, and then they start going down again, which is kind of characteristic of a parabola. So that's why I immediately think or thought quadratic. But let's go ahead and plot this and see if our picture backs up our initial gut feeling. So we're gonna go to Stat, Edit, and now we have new numbers to put in. Remember, if you highlight L1, hit clear and enter, it will empty the column. Or you can just type the new numbers in right on top of the old numbers. Whatever you find easiest. And the same for L2. Now, I'm not going to ask it to do a regression because I'm still not sure what kind of regression to do. My gut says quadratic, so that's, if I were doing this problem myself, that's where I would start. But let's graph it and see what the points look like. All right, does everybody have them in? Okay, so we're going to go back to stat plot, but we're going to go ahead and do, actually, why don't we go down to plot 2? Let's see what happens if we do that. Maybe I can't. I didn't want to do plot 1 again because, all right, I'm just going to do plot 1 again. So I'm going to go back to stat plot. Yours may have worked, mine isn't. But I'm going to have to change my Y list back to L2, which I can do. Go to list and choose L2. And now it should work, yeah. Now you're not going to see what you want to see, so you're going to zoom 9. That's zoom stat. So it zooms in on your statistics. What shape did you get? Oh yeah, that's definitely a parabola, right? So now what? Well, now I can go back to stat, over to calc, and this time I'll choose quadratic regression. Right? And it's going to give me an equation. Negative 4.883 x squared plus 15.958x plus 4.996. How does that look? Is that what everybody got?
Yes.
So we just did B. We just wrote the equation of the regression model. But again, when you put those numbers in, the data numbers, when you put them in, and you go to calc, you need to know which button to press, right? So we kind of looked at our numbers and determined that no way was it gonna be blind, right? Kind of looked at it a little more carefully and noticed that, well, somewhere in 1.2, 1.7 area, we get to our highest, and then it kind of goes down evenly, not perfectly evenly, but kind of evenly on both sides. So it looked like a quadratic would be a good fit. Usually these come up in word problems. If the problem involves areas, then that would definitely be quadratic. What if it involved volume?
Cubic.
Then it would be a cubic. So a lot of times you can get clues right from the problem when it's written as a word problem. Okay, so that's one of the things you'll just have to kind of figure out. But if you plot the points first, you can pretty much tell what you got. Okay, number 6. So now we got some new ordered pairs. Now I'm going to walk you through it and I want you to do it. Using a logarithmic regression, so they tell you it's going to be a log regression, write your equation. The residual plots provided below, what would be the coordinates of the point R? You can do that a couple different ways. And then, does the residual for the point indicate that the model underestimates or overestimates? All right, let's see if you can finish that up. I'm going to put in new data points, sorry. So we go to stat edit and start putting in numbers. And we don't need to graph them. They tell us which regression to use. So once you get them in, you're just going to stat calc, and you're choosing LN. LN, that's your logarithmic regression, LN, LN. I'll put mine up here and you see if yours matches.
So not if you write it L with the L and before the number after it, like before 1.1.
No, it has to be LN a number. Oh, wait, no, I wrote it wrong. Declan, you're exactly right. What I wrote makes no sense. This is what I have. Yeah, I have to have X, L and X, yeah, that's what it is. Yeah, that makes sense. Yeah, thank you, yes, that is what it is. A and B are right there. Yeah. All right, did everybody get that, now that I've written it right? All right, now, the residual plot is provided below. What are the coordinates of the labeled point R on the residual plot? Now, you guys, how many points are in that plot, including R? How many points are in that plot? 7. Why are there 7 residuals? Because there are 7 ordered pairs, right? So which ordered pair, what is the X that's gonna go with point R? 1.6. So could we hand calculate the residual for 1.6? Yes. How would we do that? How do we find a residual? We take the actual minus the predicted, right? And for 1.6, what was the actual? 3.3? How can we find the predicted? We use our model. This is where using your Y really helps because it's so much easier.
What do you plug in?
Plug in your X value, which was 1.6.
How do we save it? How do we save the Y value again?
Okay, we'll go through that one more time. Let me get my Y value here. So it should be 3.7183 is what it came out to be. So one more time. If you want that Y to be stored in the calculator, you have to tell it, it says store regression equation. If it says that on your calculator, store regression equation, then you put in the Y. And the Y comes from vars, Y vars, function, Y1. Store regression equation. You have to type a Y there, then you have to get that Y typed in there. If you have an older calculator, went through this the other day, I'll do it one more time, then you gotta come to office hours, folks. One more time. If you have the older calculator, then when you do stat calc, regression ln, then you have to type, once you get your linear regression selected, second L1, comma, second L2, comma, vars, Y vars, function, and then it will store that for you. Now the benefit to having it stored is you don't have to do this arithmetic and you don't have that round off error. These numbers were both rounded off, right? Okay, so anyhow, what is that? That value is negative 0.4183. So this is what I came up with for the residual for point R. So stop playing with your calculator a minute, listen to me. That's what I came up with, right? Just doing the math, right? Didn't need a calculator, well, I mean, I did it for the arithmetic, but I just did the math. Okay? Now, the other way you could have done that is to have actually put this plot on your calculator and used your trace button to see what you get. So one more time, to do that, we're gonna go to stat plot. I'm just gonna stay in plot 1, but what do I have to remember to do since I'm graphing a residual? I gotta change L2 to residual by going to my list and choosing residual. And then I can graph it. And I will oh shoot. Shoot. I'm having a hard time interpreting that graph. So here's the other thing you can do. Go to stat, edit, and move all the way over till you find the residual column. And it looks like the residual is exactly negative 0.4183. Did you understand what I just said? If you go to stat, stay in edit and hit enter, so you have your column there, L1, L2. Just scroll over, and the last list you have there are your residuals. L2, L3, L4.
Mine doesn't have those.
I don't have it either.
It doesn't have a column called residuals.
No, it just goes L6 and then it's
Okay. So it doesn't, there's nothing after L6,
No.
I have L6, blank.
and then a blank?
Yeah.
it's just the telling you.
Okay, so let's do this. Let's,
Six changes to it.
go up, highlight the blank area, get up in the blank area. Yeah, you're in the blank area, okay, then go to list. Choose residual. Yeah, there you go. So you have to, if your column isn't already named that way, you have to name it. So you're gonna name it the same way you stat plotted it. You're going to go where you want it, where you want it to say residual. So that would be where like L7 should be. So go up there, and then go into list, choose residual, press enter, and it will name that column. And as soon as it names the column, it fills it, right? And the second point is negative 4.183, right?
Yeah.
All right.
But
So-
after the 4.183 says dot dot dot, so there's more.
Yeah, well, we know there is more, because this is a logarithmic equation, so we're gonna have lots and lots of decimal places. We're generally rounding to 1,000, so. Okay, so you got some stuff to play with on your calculator, just keep playing. But now I wanna move to the next page and do some additional reviews. Some stuff I put together because, we just need a little more practice.
You or Mr. Password?
I put this together.
Might have to.
Alright, so number one, got this table that I copied from somewhere. T is the year since 2000, and F of T is the number of passengers in millions. Find the average rate of change from 2000 to 2019. Okay, we are not freaking out. How do you find average rate of change? So it'll be F of 19 minus F of 4 over 19 minus 4. Now, why am I using those numbers? Because what is my X, my T, supposed to be? Years since 2000? So wouldn't 2004 be 4? And 2019 would be 19? Okay, now the good news is, these values are in my table, so 9926.7 minus 703.7 over 15. Won't that be my average rate of change? Type that in. And I got an average rate of change of 14.867. Now let's put a unit on that, since this is an actual problem. What would that be? 14.867 watts.
Million passengers per year.
All right, is a unit million? Yeah, million passengers per year. Does that make sense to everybody? Find a linear equation for f of t. Now, I want you to do this with your calculator. So what does that entail? What are we gonna do? We're gonna stat edit, and we're gonna start putting in, yep. Remember, you're not putting in the thousands, you're putting in the 4. So 4, 5, 6. And you gotta put in both columns. whose idea was this? Alright. We're doing linear regression. Anybody come up with an equation yet? Y equals 11.314x plus 643.947.
Yep.
That look okay? Oh, and I probably should write it better than that. It should be f of t in t, right? All right, you okay with that? Now, the other day, we turned our diagnostics on, so we can actually know the relative accuracy of our data. I am not super impressed with this. What did you get for your R value? R. 0.8? Okay, what did you get for your R squared value? 0.66. Okay, so what that means is this model isn't as good as the ones we looked at the other day. They had like 0.99 things there, or 0.96, something like that. R squared is the number that tells you what percent of the variation in the data does the model itself explain. So the answer to question C, what percentage of the variation is 66.51%. That's the percentage of the data. R squared gives you the percentage of the variation. So in other words, the model explains 66% of the variation of why it's not right. R squared gives you the percentage of the variation in the data. All right? What's f of 23 and what does it mean? F of 23 and what does it mean? Anybody?
104.178.
I'm almost there. I had to resave my stuff. What am I typing in? 23? What'd you get, Alex?
904.178.
That's right, 904.178. So F of 23 was 904.178. What does that mean? What does that number mean?
43 years average, 2000.
So in 2023, the number of passengers were 904 million? Right? That's what that means? What is the residual for F of 16? Now, before you start panicking, could you calculate it by hand? Absolutely, you could calculate it by hand. I erased my formula, but how do you find the residual? You take the actual data point, which we have for 2016 is 824. Then we would find the predicted value, not using our model, right? And subtract. What else could you do? Since you've already spent so much time putting all these numbers in, you could go to Stat, Edit, and click over to your residual column. If you notice, okay, did you type over to the residual column? Did you notice that down at the bottom, it says something like residual 1, and it gives you the number. Well, which residual do we want? We're going down to,
13.
we're going down to 16. So remember, we started,
13.
it wasn't our first data point 4?
Is it, but isn't it the 13?
Yeah, so, yeah, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, it's the 13th one. So I gotta find the residual for 13. I got negative 0.977. Right? Everybody find that number? Everybody understand why we didn't go to the 16th one? Remember we started with 4? All right, next page. What does the residual mean? What does the residual value of this mean? The model overestimated, because actual minus predicted is the residual. So if that number turns out to be negative, that means the predicted was bigger. So the model overestimated in this particular year, right? If we graph them, some of them will be under, some of them will be over. This one was over. All right, you got 9 minutes. Do this next page quickly with your partner. Not as many data points to enter. Tells you this one's quadratic. Remember, to get rid of all those points you just put in, you're gonna go up and highlight L1, hit clear and enter, and you can put in your new numbers. Okay, did you guys get your quadratic model? Did you get that far?
Yeah.
Okay, now what is question A asking you? Find the x if y is 41. So if you saved, if you stored your regression equation, when you hit graph, you should see your parabola, your equation should be in there. If you then go to y equals and add y equals 41 as the second equation, and graph them both together, what would you be looking for then? Where they intersect each other. Yeah, that's probably the easiest way to do it. Since we have the technology, that's probably the easiest way to find that. See if you have any luck with that. Here is my equation. Does it look like yours? Actually, I can't even read my handwriting, so I'm gonna have to go back and see. Is that what yours looks like, your equation? Okay. And so then, oh shoot, I didn't write it down. When I found my point of intersection, which I'm gonna have to do again because I'm gonna write it in. I got x to be 5.861. So in other words, after 5.861 seconds, the ball will roll 41 inches. Anybody match that one? Yep. Graph the residual plot. All right. How do we do that? So we stack plot, right? If it's not already on, turn it on. And then make sure that Y list is residual. And then zoom 9 so you can see a better picture. And I've got points that look like this. Just roughly. Does that roughly look like what yours look like?
Yeah.
Yeah. Here's your residual plot. What is the residual for 4? Well, there are two ways you can do that. Since you're looking at the plot, you could just press trace and arrow over until you got to where x is 4. And it looks like the residual for 4 is negative 0.234. What else could you do? Well, you could always calculate it by hand, but you could also go back to stack, edit, and go over to your residual column, and you see the negative 0.2336 there? So you can get it out of there, or you can get it from the plot itself. And then finally, number 3. Put the calculator away. For some reason now, we need to be able to do one of these without technology. You already know how to do this, you did it last year, so we're just gonna get it started and you can finish it on your own. But if you were doing a quadratic regression on your calculator, the form of the equation would be this, right? Everybody knows that? So if I have the point 1, negative 3, then that means basically this, doesn't it? Right? And then if I have the point 2, negative 7.5, I could do the same thing. And then the same thing with the third point. So I would generate 3 of these using the individual x's and y's that they gave me. Correct? So what would I have? A system of 3 equations and 3 unknowns. Now, I'm not allowed to use a calculator. So I'm gonna take those three equations, and I'm gonna maybe start eliminating something. Remember doing this last year? So if you maybe just say, I'm gonna eliminate C. So you'll figure out a way to eliminate C here and here. We will go from there. 1 through 1 4 homework due on Monday.
In the name of the Father, Son, Holy Spirit. Lord, thank you for the food before us, the Irish